Hello class, good morning. So this week our topic is experimental probability. But before we begin with experimental probability, so let me define probability. So it refers to the likelihood or chance of an event occurring. So when you say outcomes, these are the result of an experiment, and an event is a set of outcomes. So probability can be expressed in words such as unlikely, likely, certain, good chance, even chance, poor chance, and impossible. I will repeat. Probability can be expressed in words using unlikely, likely, certain, good chance, even chance, poor chance, impossible, and it can be described also using numbers just like 9, 2 out of 8, 2, 8, 2 to 8, or 25%, or you can also describe it as 0.25. So we have an example here. The chance of getting a blue is 3 to 8. So because there are actually 8 parts, and each part has a color. So how many blue colors do we have? 1, 2, 3. So the numerator is the number of blue colors in this wheel or color wheel, and the denominator is the total number of parts, or it can be the total number of outcomes. Next is getting a red. So how many red? 1, 2. 2, and the denominator is 8 since we have 8 total number of outcomes. Next is getting a green. How many green? 1, 2. So the numerator is 2 and the denominator is 8 because there are 8 parts in this color wheel, and it has the total number of outcomes is 8. Getting a yellow, so we have 1 yellow, so 1 over 8. Actually, this example is a theoretical probability, because when you say theoretical probability, it is computed without actual event outcomes. So you don't need to spin the wheel. You don't need to spin the wheel to get the possible outcome. So what you see, then just compute. So getting a blue, then count the blue colors. Getting a red, count the red colors. Getting a green and yellow. So that is theoretical probability. It is computed without an actual event outcomes. So theoretical probability, so just like this one, as I've said a while ago, a probability can be described using a word or a number. The event of getting a blue is 3/8. So it is more likely to occur than the event of getting a yellow. So it means that there is a bigger chance of getting a blue color than yellow color. Next one, the events of getting a red or a green are equally likely to happen. Why equally likely to happen? Because they have the same probability, which is 2/8. They are equally likely to happen because they have the same probability, which is 2/8. Next is the event of getting a yellow has poor chance. Why has poor chance? Because yellow has the least probability, which is 1/8. So if you put the fruits, next example, if you put the fruits in the basket, then there will be 2 apples, 3 oranges, and 3 mangoes. So in total, 2 plus 3 plus 3, we have 8 fruits on the basket. So if you set or get a fruit in the basket without looking, then the chance of getting an apple is 2/8. Why 2/8? Because we have 2 apples, and 8 is the total number of fruits in the basket. So the next one is getting a banana. Why the probability is 0? Because there is no banana in the basket. So the probability of getting a banana is 0, or it is impossible. So if you're going to plot it, then they will lie in this part, since it is the probability are 1/8, 2/8, and 3/8. So there are unlikely or poor chance to happen. Next is a probability of 1. When the probability of an event is 1, meaning to say that it is certain. So the percent of happening is 100%. So a probability of 0, it means that it is impossible, and or it will never gonna happen. Or if the probability if is 1/2, then there is an even chance, or 50-50, to happen. So let's proceed with this example. A box contains 7 chocolate coated strawberries and 3 white chocolate coated. So you can see here we have 7 chocolate coated and 3 white. 1, 2, 3. So the probability of picking a chocolate coated, actually, okay, we have 10. So we have 10 coated strawberries, okay, in this box. So there are 10 coated strawberries. So the probability of picking a chocolate coated strawberry is 7/10. Why 7/10? We have 7 chocolate coated, that is the numerator, and the denominator is the total number of strawberries in this box. So there are 10 strawberries. So the probability of picking a chocolate coated strawberry is 7/10. Next, the probability of picking a white chocolate coated strawberry is 3/10. Why 3/10? Because we have 3 chocolate or 3 white coated strawberry, white chocolate coated strawberry, and there are 10 strawberries in the box. That's why the probability of picking a white chocolate coated strawberry is 3/10. So if you will express it in words, then picking a chocolate coated strawberry is more likely to happen than picking white chocolate coated strawberry. So there is a bigger chance of picking chocolate coated strawberry than white chocolate coated strawberry, since there are more chocolate coated strawberry than white chocolate coated strawberry. So let's represent it using the number line. So since there is no number line in this presentation, then okay, I will describe the probability of picking a chocolate coated strawberry, and this one is likely to happen because there is 70% chance. And for the white chocolate coated strawberry, 3/10 or 30%, then this is unlikely to happen. So that is another example of theoretical probability. Then next is the probability of picking a coated strawberry is 8 out of 8. Why 8 out of 8? Because all the strawberries in the box are coated with chocolate. So 8 out of 8 or 1. It is certain or 100% to happen. The probability of picking a mint candy is 0. Why 0? Because there is no mint candy in the box. All only strawberries. So this one is the formula for the experimental probability. So the numerator is the number of occurrences of the event, and the denominator is the number of trials. So I will repeat, the numerator is the number of occurrences of the event, and the denominator is the total number of trials. For example, I flip the coins 10 times. So after flipping the coins, I recorded that it shows 3 heads and 7 tails. So if I am looking for the probability of tail, then the numerator is 7 and the denominator is the total number of trials, which is 10 times. So experiment, here are the examples of experiment: tossing a coin, rolling a die, or picking a marble, and even spinning the color wheel. Outcome is the result of the experiment. For example, I toss a coin and the result is head, then that is what we call the outcome. So this one is an example of experimental probability. Anna rolled a 6-sided die 50 times. So it means that she rolled the die 50 times and she recorded the outcome every time that she rolled the dice. So here is the outcome. For 1, 10 times. Ibig sabihin, 10 times na nagpakita yung 1 dot. For 2 dots, 5 times. 3, 14 times. 4 dots, 6 times nagpakita after rolling it 50 times. 5 dots, 7 times. 6 is 8 times. So if you total all this one, 10 plus 5 plus 14 plus 6 plus 7 plus 8, total of 50 times. So here is the recorded data after she rolled the die 50 times. So here is the question: what is the probability of getting a 2? Getting a 2, so look at 2 5 times, and that is the numerator, and the denominator is the total number of times that she rolled a die, and that is 50. So 5 over 50, or you can reduce that into 1/10 or 10%. Next, what is the probability of getting a 3? Go back to the data. 3, 14 times. 14 times is the numerator and 50 times is the denominator. So 14 over 50, or if you will convert it into decimal, that would be 0.28, or if it is percent, 28%. Next problem, what is the probability of that a number is more than 3? So look at the data. More than 3, we have 4, 5, and 6. So what is the probability? Then get 6 times, 7 times, and 8 times. So the probability of, so the numbers more than 3 are 4, 5, and 6. So in order to get the probability, then get first the probability of 4, the probability of getting 5, the probability of getting 6. Since for 4 we have 6 times, you can see it on your book on page 412. For 4, probability of 4 then that is 6 times divided by or over 50 for probability of 5, 7 because 7 times that the 5 that shows over 50, and 8 over 50 since the 6 that shows 8 times. So over 50, which is the number of trials. Then just copy the denominator, which is 50, and add the numerator. 6 plus 7 is 13 plus 8. The answer is 21. If you will convert it into decimal, that would be 0.42, or in percent, 42%. So what we did is we add the probability of getting 4, 5, and 6 to get the probability of a number that is more than 3. For the third problem is Andy flip a 1 peso coin 100 times. So he then counted and recorded the results. So 65 times na lumabas ang head and 35 times na lumabas ang tail. And the total number of times or trials is 100. So what is the chance of getting a head? Head, we have 65 times that it shows. And the number of trials is 100. So 65 over 100, or 65% chance. Next question, what is the chance of getting a tail? For tail is 35 times. So 35 out of 100 trials, 35 over 100, or 35%. For example number 4, describe in words the probability of picking an even number in a bag containing this number. So 4, 5, 7, 8, 11, 14, and 17. So we have to describe it in words. So as you can see, we have three even number: 4, 8, and 14. 4, 8, and 14 are even numbers, and we have 1, 2, 3, 4, 5, 6, 7, total of 7 numbers. So if we're going to get the probability of getting or picking an even number, that would be 3 over 7. So it means that it is unlikely to pick a card with even number. Why it is unlikely? Because it is lower than 50-50 chance. Okay, it is lower than 50% chance because it is just around 42.86% if you will going to convert 3 over 7 into percent. On the probability scale table, 37 is closer to 0 than 1. But when you say odd, then that would be likely, since there are 4 odd numbers. For the last example, or for the fifth example, a coin is tossed and a die is rolled. What is the probability of getting a head on the coin and 5 on the die? So it means that if you rolled, okay, a coin and a die, what would be the chance of getting a head on a coin and 5 on a die? So we can write everything. So it can be head 1, head 2, head 3, head 4, head 5, head 6, or tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. The number is the number of, okay, the die or a die. And head tail is the outcome of coins. The question is, what is probability of getting? The probability of getting a head is 1/2, since the outcome of tossing a coin can only be, or rolling a coin can only be, head or tail. So head is for 1 and the denominator is the total number of outcome, which is 2, head or tail. Next is the probability of getting a 5 is 1/6. Why 1/6? Because there is only one 5 on a die. And there are 6 possible outcomes, which is 1, 2, 3, 4, 5, 6. That's why the probability of getting a 5 is 1/6. So to get the probability of getting a head on a coin and a 5 on a die, then just multiply 1/2 times 1/6. So simply multiply numerator to numerator. 1 times 1 is 1. Then denominator to denominator, 2 times 6 is 12. So the probability of getting a head on a coin and a 5 on a die is 1/2. So I will repeat on how to get the probability. First is get the probability of a head, of getting a head, and the probability of getting a 5, then multiply to get the answer. So Andy flipped a coin once and rolled a die once. He performed it 20 trials. He recorded the outcomes in a chart. What is the probability of getting a head on the coin and 6 on the die? So here is the data or the result after doing it for 20 times. So what is the probability of getting a head on the coin and 6 on the die? So we will find out head and 6. 1, head and 6, 1, 2. So there is 2. So we see that there is 2 outcome, head 6. So we can see 2 outcomes with head 6. So 1 and 2. 2. So that would be the numerator, 2. And the denominator is the number of trials, which is 20 times. So 2 over 20 or 1/10. I will repeat, how did we get the answer? Head and 6. Just look at the table with head and 6. So 1, 2. So that would be the numerator. And the denominator is the total number of trial. So 2 over 20 or 1/10 or 10% probability. For your activity, answer check your understanding on page 414. Take a photo of your answers and send it via private message. Deadline April 20.